Kyle and team for letting me share some of my experiences at GoGrid, and in particular some of the challenges that we faced in building out that network. I think some of the same things that we talked about all day today, and I think what kind of opportunities that presents for OpenFlow and this community in general. I did collaborate on this slide set with my friend Ivan Batnock, who comes from, I think recently at Rackspace, prior to that Microsoft Azure, and spent a lot of time at Yahoo as well. Can you guys hear me okay? Yeah. Cool. So, just to get started, I think the word cloud has a lot of definitions. The way that I define it is, I think importantly, and I'm not going to go over all the features with you, but I think one of the important pieces of a public infrastructure cloud service is that no single client has control or represents a material portion of the capacity of that IaaS provider, where you have just a lot of clients that represent small percentages of all your capacity. And you provide compute and storage services, and obviously, and you can pay for them as you go, and you can launch services on demand. What I think we're seeing today in the public cloud is that the majority of customers on clouds today are small to medium-sized businesses. We're also seeing IT departments of larger enterprises. I think we talked about this in the morning. Smaller departments of large companies that are just fed up with sort of how slow it is in their own companies to get resources, and so they've gone to a public cloud provider. I think there's a lot fewer enterprise users today, although we're seeing, I think, more companies, and especially some of the public clouds that are backed by telcos, that are moving more into the enterprise space. And I think there's still very little integration between public cloud networks and on-premise networks. I think we're seeing some VPN stuff happening with Amazon and Microsoft Azure, but I think it's still very, very very separate. The workloads that you run in the cloud are not really talking to or operating alongside any of the on-premise stuff as much. So, here I want to talk about what is it that public cloud network providers need from the perspective of their infrastructure and then from connectivity. And just to define the scale that I'm talking about, 10,000 hosts with about 10 to 20 virtual machines per host. I think that'll go up over time as a CPU gets more powerful, as storage goes down. We'll see a lot more virtual machines packed into nodes or into dumb zeros. But we're talking at 1 to 2 million virtual machines in your data center in terms of scale. We need API provisioning. I think this is an obvious one that we talked about all day. But not only do we need to be able to access and control the network programmatically, but that API needs to support a very high rate of change. I think today we're able to do things with expect scripts and whatnot, where we can access our network devices programmatically, but it's very hard to make a lot of changes very quickly on traditional network devices. Any-to-any connectivity is something that I'm going to touch on later, but it's something that's really, really important in this context. You want every virtual machine in your data center to have access, high bandwidth access to any other virtual machine in that data center. And the reason is that you have customers who come on, say, and they launch a couple servers, and then they want to come on a year later, and they want to add some more virtual machines, but they expect those virtual machines to be in the same layer 2 domain. They want to have everything look like one VLAN, and even more so, they want to have multiple VLANs, and they want to be able to control what VMs live in which layer 2 domain. And that's a very, very hard problem to solve. It's with traditional VLANs, like we pointed out, there's 4,096.1Q tags that that you can assign to a traditional LAN. When you get to the end of that, then you have to kind of deploy a new pod. And so you can solve this problem by just maintaining excess capacity in every single one of your pods, just to keep extra kind of excess capacity in line for any new customers that come up. But that's really, really expensive. Layer 2 isolation, all customers expect to have their own VLANs. And then there's going to be a combination of soft and hard network devices as well. I think today, we need to be able to control, and like in addition to the traditional plumbing that we have, there will be a V-switch in every hypervisor. And so your network goes from thousands of network devices to tens or hundreds of thousands of network devices. Tenants also want fair, guaranteed resource distribution. They want to be protected from another customer coming onto your infrastructure and taking up more than their fair share and impacting the service that you're giving them. And high cross-sectional bandwidth. I think this is where I think traditional enterprises have built kind of networks like a chimney, where data flows in from the top and then down your application server to your storage area network. With the service provider networks, we need to provide high bandwidth between virtual machines and all across the data center, because you're going to have tenants who are building 3-tier, n-tier architectures, and they don't know where their VMs are, and they shouldn't have to care. And then, of course, all this has to be cost effective. I think there's two major requirements that we're asking for from our vendors, and that's, one is that they're cost effective, right? That I have enough options where I can, feel comfortable that the vendors that I'm buying from are seeing cost competition and the price competition from the market, so I can get the best price. And I also want to avoid vendor lock-in. Right? I want to be able to make future decisions on purchasing for my network capacity and not be constrained to only buy from one vendor because I've implemented, a proprietary network protocol for my network. From the perspective of the business and what the business needs, and also what we want to, the service that we want to provide to our end users, the product is that we need to maintain a high level of utilization on our servers. At GoGrid, we tried to maintain 80% utilization of the RAM resources on the nodes, which is really, really hard to do when you consider that you need to make the RAM in all your servers available to any customer in the data center at any time. And that's complicated when you're dealing with the compatibility of guest operating systems to your hypervisors, because you end up segmenting across different flavors of hypervisors that only support kind of different virtual machines, which is a software problem, which is hard enough to solve. But when you also have to segment your network in pods, like we talked about, then that creates even more islands of capacity that you have to manage across your data center. Growing on a just-in-time basis, we want to, infrastructure is very, very expensive. It costs $1 million to open up a new point of presence. And so you want to be able to limit how much network capacity you have to buy to grow. And minimal customizations, I mean by that, you want to be able to develop, to build a service that can meet as many of the requirements of your customer base as possible. You don't want to build a product that only serves a small segment of the marketplace. You want to do that while minimizing how many customizations you have to make to support those end users. I think all of us have built, small little one-off configuration settings for a particular customer, or people want things wired in a specific way, and so you end up having the risk of having just a lot of customizations in your network. That is, kind of ultimately means that it's very hard to support and it's very hard to plan around upgrading and servicing those customers. And you can't scale your business without, kind of scaling and adding more people. And this is the last point that I'll talk about also later on, but agile product development. I think one of the challenges of operating a public cloud hosting provider is that, at GoGrid, when we started in 2006 and 2007, we had to write all of our own control software. We didn't have an OpenStack, or we couldn't leverage Citrix or any of the existing cloud technologies out there. And so we delivered everything, and we built all that ourselves, which was a lot of fun. But it's also very hard, it turns out, to deliver a development environment or a test environment for, for an engineering team when your environment has to span everything down to layer 2, right? It's very expensive to be able to test a new feature to launch a virtual machine for an engineering team of 10 or 20 or 30 people. So what you need to have is ways to quickly provision entire infrastructures on demand and very quickly for your engineering team, which is very, very hard to do. And it's something that the systems guys are way ahead of the networking guys in that. Someone mentioned Chef and Puppet earlier, where I can describe today I can describe my system and application configuration with a configuration file, and I can check it into a software repository, and then I can check that out, and I can apply it to any system that I want very, very quickly in an automated way. That's very, very hard to do today with network configurations. It's possible, but it's a lot harder to do. And so I think that's one of the things that I think SDN and OpenFlow is going to really, really help with. From a product perspective, customers want to feel as if they can burst on your network and launch as many VMs as they want and as their business needs. I think Amazon is to blame for that. But what that means, and this goes back to the 80% kind of utilization of resources, is that 20% free. If you maintain that static, that 20% buffer for your data center over time, that number should, as an absolute amount of resources, should go up as your entire capacity in your data center goes up, right? 20% of 1,000 is a lot less than 20% of 10,000. But that only works is if your entire pool of resources looks like one pod. And so the better you get at minimizing how many of your resources are stranded in a data center, the more your customers can burst. Kind of customers also want to be able to add as many VMs as possible into their layer 2 domains, and don't care, when they launch them, and quality of service. And they also want to be able to move their virtual machines, between their VLANs. What they also want is to move the virtual machines from their on-premise to the cloud, which is a wholly, a Grail problem that I think OpenFlow and SDN will help us, solve as well. And then, price competitive. We want to be able to do all of these things and be able to compete with other providers in a business that, kind of largely, if not already, will become commoditized. I think launching virtual machines in the cloud is something that is going to, if not already, is going to, kind of become a commodity in the future. So, what are some of the limitations of how networks were done in the past? And I think that it all comes down to that the distributed model is broken. The complexity of managing a distributed configuration and decision making increases exponentially with the number of virtual machines that you have in your data center. And there are limitations to in a number of routers in your OSPF kind of area, or the number of cascaded switches that that you can have, or how quickly these things converge without having transient effects during convergence. And this happens because of inherent limitations to the protocols that we use. MAC addresses. There's a limit to how many MAC addresses we can have in a pod or in a rack of servers. Spanning tree protocol topology limitations. And then Cisco and Juno OS configurations don't really scale that well. Everyone who's managed a huge configuration file knows that it's you hit upper limits to how quickly you can save that configuration file, how quickly can you apply it, and it's just kind of becomes very, very unwieldy. So what I think needs to happen is if we want to move away from a topology where pods connect to top of rack switches, or pods with top of rack switches, go and uplink to a core network, then we're going to need some sort of layer 3 aggregation, some layer 2 over layer 3 tunneling to be able to aggregate all of that and extend your layer 2 domains across different, various pods. And that's not impossible today, but it's really hard to do at the scale that we're talking about. And that's because of lack of programmatic access. Existing technologies have a very, very limited API, and monitoring, kind of doing things with expect scripts or monitoring your network devices with SNMP and scanning all of those MIBs just has a lot of complexity. And so we have to put a lot of hacks in place to get that done today. And then, also, proprietary solutions are very hard to integrate with one another, or like impossible, because there's, various vendors use different names and nomenclature to describe similar things. Think about load balancers, where every load balancer vendor calls virtual, some call servers real servers versus virtual servers, and it just gets very, very difficult to integrate. From the business perspective, I think that we end up segmenting our capacity into pods. Maintaining the layer domain per customer is very, very difficult or impossible. It's very hard to migrate VMs around the data center. Adding more capacity is very, very difficult as well. It's a very manual process. And then customers end up, either running out of capacity or not having the kind of service that they need from you. And then, without a different solution, it's very hard or impossible to enforce quality of service across your entire data center today. And so I think that, we're in a paradigm shift where, the requirements that our current network technologies were built off of are just not suitable for IaaS clouds, because they were designed with with a completely different set of assumptions in mind. Legacy network devices were conceived to be deployed one by one, without a central repository of configuration. They were designed to be plugged into the network and then just have the network protocols figure out what to do with that traffic. They were managed by humans. The scale was a lot lower, and I think also importantly that innovations. I think it was a lot harder to get anything done. I think there's a lot of chefs and cooks in the kitchen, and you needed to kind of petition the IEEE to or some vendors needed to do that to get actual things done. And that really just doesn't work in today's world. I think with what larger enterprises and what clouds need. We want to be able to quickly auto-provision networks only using a configuration file. Right? We want to be able to pre-build entire racks of servers and describe the networking topology with an XML file. And we want to be able to do that and drive a single API. And we want to do it inexpensively. And then we want to be able to innovate without having, to wait for AS, or any other kind of standards body to approve our blueprints. And so I think OpenFlow and software-defined networks are poised to be the technology solution that's going to help us to accomplish those things. I think what I get excited about is scalability. Scaling the controller and the server that the controller runs on is a known problem, right? It's a known problem that we have really, really good solutions to. Today you're constrained by the CPU and by the hardware that the network vendor puts into your network device. But the OpenFlow controller lives outside of that, and so you can scale it up and you can scale it out, just as you do like any box today. And just to be clear, that the MAC address problem that I talked about earlier is not inherent or it's not resolved by software-defined networks, right? I think if layer 2 over layer 3 tunneling is the ultimate solution for that, it's possible to do that now. It's just very, very hard to do at scale. And so by creating a new protocol for layer 2 over layer 3 tunneling, OpenFlow solves that via orchestration and the way that we can provision OpenFlow networks. And so it kind of also is poised to to give us a lot of the better integration things and kind of the things that we've been talking about today. So some of the cool new capabilities that I see being enabled by software-defined networks, I think we'll be talking about that more later, but really the ability to treat network infrastructure as code is a really, really exciting thing. I should be able to, the holy grail, I think, is to be able to rebuild my entire n-tier network infrastructure, with only access to an IaaS provider, access to a software repository, and my data. And I should be able to write scripts to be able to rebuild my entire infrastructure in less than an hour across any cloud provider if I wanted to. And that gives me just incredible power. Not only does it make it easier for me to do development and testing and be very dynamic with how I build software, even as a cloud provider or any provider, but then I can also implement, finally, have actual disaster recovery plans, right? How many people here have a DR plan that, that is documented somewhere, but we never actually tested it, or it's very, very hard to test or impossible to test? I think SDN is the final piece, I think, following all the system audit provisioning stuff that we've already have a good handle on to allow us to do that. I also think it's interesting, and kind of something that I think that I missed kind of talking about earlier, but allowing customers to use, to decouple the IP space that customers use from the underlying infrastructure. And it's something that I think is really, really hard to do today in an automated and flexible way, but something that software-defined networks will help us do. Also, letting customers manage their own layer 2 domains, adding as many as they want, and then moving virtual machines across layer 2 domains is a really exciting thing, I think. And then end-to-end quality of service is something that we can do with SDN networks that we can't do today. So I think that's it. I'll open it up to any questions. Yeah.
So, Dave Meyer, Cisco. I wanted to ask this question about 5 times during your talk. This is kind of a question about where you see this sort of convolution of sort of, society and SDN. And in particular, what do you think is, if anything, is the interaction between SDN and the DevOps movement?
I think that they are perfectly. I think that the DevOps movement is pushing it forward. I think that DevOps engineers are going to be the first users of software-defined network APIs, and I think someone earlier mentioned that a lot of new technology comes in through the back door of companies, and I think that as OF becomes more mature, I think it's your DevOps engineers that are going to start leading the way to building the applications that your business needs, leveraging OpenFlow APIs and OpenFlow standards to actually solve problems that either were impossible to solve today or that they've already hacked together in some way that's not really flexible. But I think that it's those guys that really, really want this too. Yeah.
One of the things that strikes me is we all talk about that network infrastructure as a code, or Doug Gomer's Doug's statement to Matt that we need to operate network as a device. So in the OpenFlow protocol, it starts still at device level. We are just still talking about the flow. Is there anything that starts at the network level that, hey, there's a controller has a device, APIs up from controller for the applications? So I mean, we're starting at still at the switch level, and I'm just trying to understand that what is there for controllers and how for applications.
Well, I think that those applications are still being built out, right? I mean,
But is there any standardization or effort in the open flow for that?
Is the question due?
There's a standardization question. There's also sort of a controller product question.
Yeah, but both are kind of tied together because we are still looking at open flow at the switch level, where we're just talking about flows and actions. But I think here all we're talking about networks and provisioning, CapEx. There's just a lot of good value. It's just that I'm not connecting the two together.
So
we still have a lot of development to do.
Yeah. So I think it's not impossible today to be able to apply, let's just say in the simplest example, right? To take a Cisco configuration file, right? Use TFTP or something to pull that config off of your network device, and then check it into a software repository, right? And then if I want to go spin up a whole new network or a new Cisco network device, I can just check out that configuration, I can copy it onto that network device, and then I can kind of restart it, and then it comes up, right? I think that's possible today. I think what's really hard is using those tools and that mechanism at scale, at a huge scale across 1,000 or 5,000 or 10,000 network devices. It's really hard to do that if you don't use REST-based APIs, and if you don't have access to launching controllers, right, in a way that's really, really easy and quick. Right, launching a new Cisco network device and plugging it in is really still today a manual process that requires a proprietary network device, right? But I can launch an OpenFlow controller on a Linux box, right? And that just looks like a basic, a basic Linux application. So it's just a lot easier. I think it's leveraging a lot of the existing, paradigms that we've used the past couple of years for launching systems. I think in converging, I think that along with controlling networks, which is the exciting thing.
I guess to rephrase is like the abstraction that Matt talked about, that basically deals anything above it, it addresses as a controller rather than the devices underneath. Is there such a thing?
So I think if you look at sort of the three-tier model, if you will, of OpenFlow, saying, hey, there's switches, hey, there are controllers, hey, there are applications on top of controllers. I think you heard from Matt, here's somebody who's built his own applications, right, for his own use on top of raw controllers that then control the network. If we look at, I think, the state of the art of controllers, and more specifically of the applications that are riding on top of controllers, if we snapshot state of the art today, not all of which is open source yet. But that's where I think you're starting to find more and more of the more experiments and more successful experiments of the higher level abstractions. Because getting those right is really, really hard. I mean, getting those right in terms of making them very, very intuitive. I think the best way to answer that is actually the demo session. I mean, that's where you're going to see a mix of both the open source and some commercial product as well. But I think that's where you start to see the commercial products are starting to lead the charge in terms of the abstraction layers up above. But it's going to take some experimentation to get that 100% right.
Yeah, and I think there are a couple speakers on the schedule for tomorrow who may, I know have done some research. Some researchers doing research in that area. What's the higher level abstraction that you program a network? So I don't know if they're going to talk about that, but I know that some of the speakers tomorrow have done some research on that.
So I would have two questions, so I'm moving really from Cisco. So one is about the entry point of using OpenFlow, especially in focusing on the data center, and the other one would be about multi-vendor support. So the entry point, do you think in the beginning it's sufficient enough to have just having V-switches doing are controlled by some, say, NOx controller or whatever, right, and without having hardware acceleration in the core network? Do you think it's sufficient for the beginning, or is it the right entry point? Or?
Sure, yeah, I think so. Because, I mean, that, and so, I think that today all your VMs are being switched with a top of rack switch, and that is just not very efficient, right? I think the more we can push state to the edge and move those decisions away and closer to the actual compute, I think is good, and I think that's a great first step. Yeah.
So you see weak slants and something popping up where you're doing your layer 2 or layer 3 encapsulation on the vSwitch basis. So you no longer have to deal with the layer 2 in the core network.
I think the important thing is that I want to be able to control that along with my hard devices as well, right? I don't want to have a separate control mechanism for my soft switches.
But if your core network is just doing layer 3 forwarding, they don't care about what's inside your layer 3 packet. So
True.
would make it easier overall. The next question is about the expectation about multi-vendor support. So I had this seen on the slide, to be independent and no longer have any vendor lock-in. And I think for me it looks like, so it's like you're asking vendors, they're like, look about the disks and say, okay, I have a NetApp disk shelf, but I want to hook up this NetApp disk shelf to an HP or to an EMC storage controller. So what's the expectation from having multi-vendor support? Like you have built your own OpenFlow controller, and now you have some hardware from Cisco, HP, Juniper in your data center, and so where are you going to open your core? So if you have a tech service request, so who are going to call?
Sure.
So it's,
I think I'm the wrong guy to ask that question to, because we built GoGrid with all white box servers and all open source software everywhere. And no SANs. I hate SANs.
yeah.
And I hate SANs because they're a single point of failure. They're all the things that you talked about. They're very hard to manage. Just, you need proprietary skills to manage them, and ultimately, your spindle to VM ratio is never going to be what it's going to be with direct attached storage. But I think the concerns that you raised are exactly the concerns that we were, raising in 1998 when Linux came out to challenge Windows in the enterprise, where people were scared. They were scared. Who do I call if my Linux box doesn't work? And I think we talked about that earlier today as well. That it's scary to push a button and then have that go out to 5,000 devices and make a change. But I think that some companies and some teams will be more comfortable taking those risks. I think the people that do that have a responsibility to come out and really tell their story so that everyone in this room can start getting more and more of a level of confidence and comfort, and then we can learn from each other that way.
Would you agree that there's there's a big line drawn between what the cloud providers, or let's call the customers or the people which are not afraid about compiling their own Linux kernel are doing versus what a typical enterprise customer is doing?
I don't know. I haven't ever managed a huge enterprise network. I think it's not that. I don't think that there's a clear line. I think even in huge enterprises, you'll have teams who are, I think, maybe want to take more risks or are more forward-thinking or innovative. And I think that I think it's those people in the companies that will that will be kind of pushing forward these ideas and really trying these things out.
Yeah, you were looking over here. I would agree. I mean, even within our shop, there's the high performance computing team who we go build whatever, right, and load up 8 different kernels in the same day to make something work. And then there's the enterprise team that runs our enterprise VM infrastructure. Very different set of people. So it all depends on what group you're working with.
Thank you.
Yeah.
Hi, this is Gautam from Cisco. So I have a question on your section of network as a code. So you talked about standardizing APIs. I mean, that part is fine, but how would you standardize the behavior of those APIs? Like, executing the same code on different platforms could result in dramatically different results, right?
Absolutely, and I expect over time for all the innovation to happen underneath the API layer, right? I think that the API syntax, right, and the code that we write to actually generate commands should stay the same. I shouldn't have to rewrite the integration that I have with my application to your technology, but you should be making that technology better on the back end all the time. And I think that's the kind of competition that we want, to see. I think when you talked about public cloud APIs, there's no question that the Amazon EC2 Compute API, it's not a great API, but it is the standard now, right? Like no one's going to come out and write a new API and then have it be as widely adopted as EC2's API. So for better or for worse, it's what we got. But you know, you see projects like OpenStack who have re-implemented that API with different plumbing on the back end, and I think that we'll see a lot, you know, like a lot more of that happening. And I hope that the same thing will happen with, I think, you know, SDN APIs.
Right. I mean, it might cause problems when you interoperate different implementation of the same API, right? Because these are not fundamental operations like x86 instruction sets.
I don't know if I believe that really. I think if you, I think if the APIs, if the syntax of the API is at a high enough level where it's not tied to any specific vendor features, and that, you know, we standardize on the error codes, that will happen, I think, as the API gets more and more mature. I don't know if I agree with, you know, kind of with your statement. I think there'll be different versions of them, and those versions have to be backwards compatible. Right.
Can I make one comment? So the API, so there's the northbound API, which is talking to a controller or a collection of controllers. You then have the API from the controller to the switching elements, which is basically a protocol. I would argue that in the networking world, we've figured out interoperable protocols some time ago. You know, I don't need Cisco routers to only talk to Cisco routers if I'm running BGP, or Juniper's only talking to Junipers or whatever. We've figured out quite some time ago how to make protocols and their state machines interoperable. This is the same thing again. It's a fairly small set of primitives if you look at the OpenFlow standard. If we as an industry cannot make that set of primitives interoperate, we've got a problem. I would say, as you said, there's a whole lot of innovation. Different vendors have different ways of, you know, well, we do this differently when we see this kind of BGP packet, and we do, you know, and there's some innovation there. But we all talk the same protocol.
Okay. Thanks, everyone.
Maybe one last question.
Just one last question. Stu Bailey, Infoblox. So this is just a business case question I'm just trying to explore. From the enterprise use case, it seemed clear there was kind of real dollars in terms of management and other things that were exploding that seemed to drive for OpenFlow some economics around investing in it. Your presentation is a little more challenging because there are some hard things to do, but we don't want to pay very much for it. Right. So are there things that if you adopted OpenFlow, you as an industry, the cloud computing industry, could provide that then, you know, would drive higher margins or allow you to pay into an ecosystem? So kind of co-investing. It's a bit challenging for a vendor to say, okay, we'll give you something at a low price that's kind of hard to do. Right.
Yeah. Well, I think, I don't know, we spent a lot of money on network devices at GoGrid because it was really important for us. You know, I think our philosophy with cloud computing has always been that all the control stuff is cool and it's exciting to launch a VM in 5 minutes, but none of it really matters if the VMs are reliable, stable, and the network is really, really fast. Right? So we spent a large amount of money on making sure that the network infrastructure was really solid. And so I think that we'll never, I think that providers will never ever, you know, be cheap about that, I think, ultimately. But I know that, you know, that's a tough question. Is there any one feature I think that we would have wanted from OpenFlow that we didn't get? I think one of the big ones.
Or I guess I'm saying, is there new capabilities that you can provide to your customers if you assume OpenFlow is there, that could drive then margin to your business, which may pass through into the vendor community, into your vendor community? Maybe not answer that now, but I think that would be good to hear from the over time from the cloud and service provider.
Yeah.